Download this code from codegive.com, link in the description below. Python urllib, and urllib2, legacy, HTTP error 400 bad request, a comprehensive tutorial. The HTTP 400 bad request error signifies that the server couldn't or wouldn't process the request due to something wrong on the client side. This isn't a server-side error, like a 500, it means your request is flawed. This tutorial explores the causes of this error within the context of Python's urllib, and its legacy predecessor, urllib2, libraries and provides strategies for debugging and resolution. Understanding HTTP 400 bad request. The 400 bad request error can stem from various client-side issues. Incorrect request syntax. The request's format, example malformed headers, improperly formatted URL, doesn't adhere to HTTP specifications. Missing required parameters. The request lacks crucial data the server needs to process it. This is common in POST requests where certain fields are mandatory. Invalid request data. The data sent in the request body, example in a POST or PUT request, is invalid, incorrect format, wrong data type, or out of range values. Conflicting request parameters. The request might contain contradictory parameters. Request entity too large. The data being sent exceeds the server's limitations. Client-side errors in the request body. These could be incorrect JSON formatting, wrong encoding, or other format-specific errors. Python's urllib, and urllib2, libraries. Before Python 3.10, urllib2 was the primary module for HTTP requests. In later versions, urllib became the consolidated library. The core concepts remain the same, but the syntax differs slightly. We will focus on urllib, for Python 3.10+, but will show equivalent urllib2 code where relevant for illustrative purposes. Note, urllib2 is deprecated. Scenario, a POST request failing with 400 bad request. Let's imagine a scenario where you're submitting data to a server via a POST request, and you encounter a 400 bad request error. Example, urllib. Example, urllib2, legacy, for Python 3.10. Debugging a 400 bad request. 1. Examine the server's response. The e.read.decode, or e.read, in urllib2, in the except block is crucial. The server often provides detailed information about why the request was bad. This message can pinpoint the problem. It might indicate missing parameters, incorrect data types, or other specifics. 2. Check request data. Carefully review the data dictionary. Are all required fields present? Are the data types correct, example integers where expected, not strings? Are there any typos or inconsistencies? 3. Validate the URL. Ensure the URL is accurate and points to the correct endpoint. 4. Inspect headers. Verify that the headers, especially content type, are set correctly and match the server's expectations. For JSON data, content type, application/JSON is essential. 5. Test with a tool like Postman. Tools like Postman let you construct and send HTTP requests manually, allowing for fine-grained control and easier debugging. Compare your Python request with the one you build in Postman to identify discrepancies. 6. Server-side logs. If you have access to the server's logs, examine them for more information on the failed request. 7. Handle non-JSON responses. If the server doesn't return JSON, adjust your decoding accordingly, example use .decode, UTF-8, or other appropriate encoding based on the server's content type header. Example of a 400 error due to missing parameter asterisk. Suppose the API requires a token parameter. The following code will likely result in a 400 error. Correcting it, assuming the token is me secret token. By systematically checking these aspects of your request, you can effectively diagnose and resolve the 400 bad request error when working with Python's urllib, or urllib2, libraries. Remember that the most critical step is carefully examining the detailed error message returned by the server.